Okay, here's an example of a problem using composition of functions, number 62 in Axler's book. Suppose f of x equals ax plus b and g of x equals cx plus d, where a, b, c, and d are numbers. Okay, so they're both linear functions. Show that f composed of g, that's a little circle, not fog, and g composed of f are equal if and only if d times a minus 1 equals b times c minus 1. Okay? So I have two fun facts here, and I'm supposed to say basically those are the same thing. So here we go. Here's what I'm going to do. I'm going to say, well, let's start with supposing these two things are the same. So let's see. So f of g of x equals g of f of x if and only if, or exactly at the same time as, or this means the same thing as what? Well, f of, what is g of x exactly? Well, g of x is cx plus d, and g of f of x, so that's g of, remember this composition of functions, I take the inside and I put it inside, ax plus b. Now, it's so important that you remember f and g are functions. These aren't functions, right? Those are numbers. X is a variable. So, this is exactly the same statement as that. Well, another way to say f of this expression is actually to plug it in. So, this is the same thing as saying f of cx plus d. I'm going to plug that into the definition up there. A times cx plus d plus b, right? I put in the input. So that's actually what this really means. What's the right side? G of this mess is c of times the mess plus d. C times the mess plus d. Okay, well, let's just sort of see what happens when we actually distribute this. So saying those two things are equal is the same as saying acx plus ad plus b equals cax, or I'll just go ahead and write it that way, plus cb plus d. Well, you can see that acx, since these are commutative, multiplication is commutatives, and cax cancel, right? Those are the same things. So really what I have is AD plus B equals CB plus D. Now I'm looking up here. This is really what I want to say it's the same thing as. Let's see. So I guess D's are all on one side and B's are all on the other side. So what am I going to do? I'll leave AD over here. I'm going to subtract D over to the other side. I need on this side to leave CB over here, and this B term, I've taken care of that term, that term, that term. That B, I need to subtract it over to the other side. So this equation is exactly the same as this equation. Now I'm going to factor out the D. This is just the same thing as D times A minus 1. Well, that's a good thing. That looks a whole lot like what I've got up here. Times B times C minus 1. Now, this equality is the same thing as this, is the same thing as that, is the same thing as that, is the same thing as that, is the same thing as this equation. And since they go both directions, that means this is the same thing as the original, and that's how you prove it.